All right. So as I said, this this is a very famous. Well, I don't know how famous it is, but this calorous impact, or this calorous basin. Anyhow, yeah. So this was a giant impact. Some people actually have done calculations that if this object that hit Mercury was just slightly bigger, I think if I remember correctly, it was like 10% bigger than it was. It would have actually broken Mercury up into into little chunks, and there wouldn't be a planet Mercury. All right, so it turns out, of course, the Moon has a very low density. And that has to do with the what happened to all the iron in the Moon. Anyhow, or the object that actually crashed into the Earth, as we'll talk about. Anyhow, the Moon doesn't have a magnetic field because it just doesn't have enough iron, and it doesn't have a molten core, the way the Earth does. So there's no differential rotation. The crust, as it says here, the crust, of course, is thicker than the Earth, and it's thicker on the side opposite, in the direction opposite of the Earth. Mercury is even denser than the Moon. It does have a weak magnetic field, so if it does, of course, there has to be moving charge, which moving metal that's rotating around in the core, in the molten core. But Mercury rotates extremely slowly, so it's a very, very weak magnetic field. Let's see. Where did the Moon come from? All right, so we think that there was a giant object, roughly. Of course, it's not Mars, but it had to be about the size of Mars in the very early stages of the solar system, like 4 billion years ago, something like that, where this object collided. And remember, in the early stages of the solar system, our understanding of the solar system, there were lots and lots of collisions. Basically, you can kind of think of the planets that we now have are, the things that survived after all these impacts, and really the impacts helped create the planets, when you go back to the very beginning of the solar system. All right, so anyhow, this Mars-sized object hit the Earth at a glancing angle, not direct on, and the computer models have actually shown this, and basically what happens is this Mars-sized object was completely vaporized on impact, and it actually turned the Earth molten, and then the Earth, of course, cooled down and solidified again. At least the crust solidified, and really what happens is the heavier, denser materials that made this original object up, this Mars-sized object, the denser material ended up, a lot of it, on the surface of the Earth. And actually that turns out to be good for us because, we mine we don't have to dig down too deep to mine for iron and nickel, which of course has helped build our society. So that's a good thing. And the computer models actually show that after this impact, over just a short amount of time, the material coalesces again. This leftover debris, this vaporized material, coalesces again into what we now think of as the Moon. Well, not think of, it's what our Moon is. So the Moon had this impact, by the way, is called the giant impact theory, and it's actually the best theory we have. For years before the astronauts went to the Moon, there were lots and lots of competing theories. The I mean, I can't name them all, but there were lots of theories, you know, where the moon was somehow captured. That's, I think, called the capture theory. Another one was the co-creation theory, where the moon and the Earth were created at the same time. But the astronauts brought back, of course, the moon rocks, and the evidence shows that the moon and the Earth came into contact with each other, but there's enough, the difference in isotopes is great enough between the moon and the Earth that they are actually different objects. So they didn't form out of this exact same material, but they certainly exchanged material with each other when this impact took place. All right, so this is just going through the history of the. So of course, 4.5 billion years ago is the formation of the entire solar system, including the sun. Lots and lots of collisions were taking place, and then roughly about 3 billion years. Let's see, what is this time before present time? Oh, so about 3 billion years ago, volcanic activity on both the moon and Mercury ceased, and I mean, so they look very similar to each other. Of course, just remember Mercury has those scarps, these giant cliffs all across. Well, not across the whole planet, but and actually, there's a theory for why those scarps occurred, and we think what happened is after Mercury formed, it actually shrank. The material that was Mercury kind of shrunk inward on itself, and it caused the crust to leave evidence of that, and that's what those scarps are. All right, so good. So we're done with this one, and we'll move on to the next chapter in the next video.